And welcome to SanfordFlipMath. Welcome to SanfordFlipMath. You might have heard that twice. This is AP Calculus from the Finney, Demana, Waits, Kennedy book, and this is live in class. And what we're doing is going over one of the homework problems. This one's from section 4.6, which is about related rates, from page 252, number 18. Thank you to our authors for slapping this bad boy together. All right, so here's the synopsis. I have a hemispherical water reservoir, in other words, a water reservoir that is half of a sphere. And when we have the water in there, it isn't always the entire half of the sphere that's full, and so the volume of what's left is given by this lovely, and I use that word lovely in quotes, formula. And we are told that the water is draining from this. The wording says water is flowing at a rate of 6 cubic meters per minute from the reservoir. So I made a little note here that the water volume of the water is changing at a rate of 6 cubic meters per minute, and it's negative. Why is it negative? Because the water level is going down. The volume in this reservoir is going down, so it is getting smaller, so the rate of change is negative. Okay, yep. 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 If the water was flowing in, then it would be positive. Yep. So it's all about, is the quantity in question, in this case volume, is that volume getting bigger? If so, then the rate of change is positive. If it's getting smaller, then the rate of change is negative, which kind of makes sense if you think about what happens with slope. When y values get bigger, the slope is positive. When y values get smaller, the slope is negative. When we get into these kind of contexts, it's, we kind of lose track of what that rate of change is really about, and that's really what it is the slope of the volume, or the rate of change of the volume. Okay, so that's negative. And the basic process is still the same. Write an equation including all of the quantities in play. They wrote that for us this time. Yay! Take the derivative with respect to time. Remember, time's not in here anywhere, so when we do this derivative, we're going to have to do some d something dt's anytime we do a derivative. Okay, and then at the end of this silliness, we'll substitute in what we know and solve for whatever it is we don't know, okay, or whatever they're asking for. In part A, they're asking for how the water level, the height, is changing with respect to time. So we want dy dt based on this lovely sketch. Okay, I need to note that there are two different r values in here. One of the r's is the actual radius of the tank, and that's big R. Okay, so this thing is the radius of the tank. Little r, remember that really this is a spherical kind of thing, and little r is the radius of the water at any time. Okay, so remember, if we're talking about a sphere, we're talking about water laying in the bottom of this, and the top of it makes a circle. The radius of that circle is little r. Okay, not really an issue right now because it's not in our equation. It doesn't become an issue until we get to part B. Okay. All right, so at this point we just need to do a derivative, and now before I do that, is big R changing? So if it's not changing, because that's the radius of the tank isn't getting bigger or smaller, it's just how much water is in there is getting smaller. Okay, so I can just substitute that number now. Remember, you can't substitute a value that is changing, but big R doesn't change. So I'm going to go ahead and rewrite this. Volume equals pi over 3y squared. Now 3 times 13 is 39, so I'm just going to say 39 minus y. Okay, so again, this was 3 times big R, 3 times 13, so 39. One other thing to consider here, and that's the form of this. If I do the derivative now, I'm going to have to do a product rule. And I personally think this would be a little easier to work with if we say all of this times 39 and all of that times y. Now I know it makes a lot of stuff, but that stuff, it's still going to be a couple power rules instead of having to work with a product rule and all that kind of stuff. So I still think it's easier to work with. Is that okay? Here we go. All right, so we're going to distribute. Now pi over 3 times 39 is going to be 13 pi. and then minus pi over 3y cubed. And again, I'm just doing that because I think doing the derivative with respect, well, doing the derivative is easier with a couple separate terms. Okay, so dv dt equals, so this is going to be 26 pi y dy dt minus, well, 3 times pi over 3 is pi y squared dy dt. Now you might decide that maybe the product rule was easier because now we have to just, we're going to have to factor out a dy dt at some point, but I don't really care. Okay, and I'm sorry? This 3? 3 times the 1/3, so that canceled out. Question? Sure. Okay, so I've done the derivative now. So I can start substituting values in. So for instance, dv dt, I have a number for that. I think it was -6. Yep. Okay, so I can start substituting. -6 equals, I can also put in the y value here. And I can put in the y value here. And so I can start, most people are more comfortable working with the numbers once we have the numbers. So I'm going to say 26 pi times 8, that's the y value, dy dt, minus pi times 8 squared dy dt. And so, yeah, I'm going to have to factor out this dy dt at some point here, and I'm going to clean this up a little bit first, I guess. 26 times 8, 216? No. I don't know. What's 26 times? Yes. We okay? Okay. All right. 8 times 26. Well, 8 times 25. What is it? 208? Okay. Thank you. So 208 pi dy dt minus, this is 64 pi. Okay, so, and I can combine some like terms here. Let me do that. It's maybe too far. -6 equals, so 272 pi? No, it's minus. $144. So I actually didn't have to do any distributing or undistributing. I was able to just combine some like terms. Divide by 144 pi. So dy dt equals negative. Somebody typing? So it looks like negative 0.01326 something something something. Did you divide by -6 divided by all of that? Mm-hmm. So I got 0.013. So obviously we need to be careful how we type this in. If you don't put the parentheses here, I believe what it's doing is -6 divided by 144 and then taking that answer times pi, and we want the pi to be in the denominator. Okay. So did it specify any this is quick little note here. My units were all in meters and minutes, so this is meters per minute. Now, I know my book lists the answer in a couple of different units, and I guess that's just in case somebody has a preference. So if you switch the meters to centimeters, it'd be 1.3, -1.3, etc. Quick little note here. Why is this rate negative? Yeah, if we have water going out, what does y represent? The water level. So if there's water coming out, then the water level is going down. Okay, so things like that should make sense. Okay. Part B. Okay, so that was part A. Part B asks, I believe it's dr dt. It says, what is the radius of the water's surface, oh, what is the radius? When I think it was still 6 deep, right? Oh, I'm sorry, what is the radius r when the water's of the water's surface when the water is y meters deep? All right, well, we need to really go back to the picture and see how this all fits together. Okay, so we want to focus in, and that's kind of a small picture to be looking at. All right, I guess I need to draw it bigger. Okay, so remember that this is a sphere, or half of a sphere. Okay, if I look at this whole thing, okay, then the radius of the big sphere is this 13. So that's that radius, it's that radius, it's that radius. All of those are 13. Now, obviously, my bowl's a little deeper than it is wide, so we'll just roll with that. Okay. Now, little r is what they're asking about, and little r is the radius of this circle of the water level. Okay, so I have the water level here. It's at a little different spot. And then the question is, how do I relate the y to the r? They do at a specific point, but I think in part B it just says, what is the radius r of the water's surface when the water is y meters deep? And then part C says, at what rate is the radius changing? So right now we just want r equals. In part C, we want dr dt when it's 8 meters deep. Okay, so I think the idea is that we're going to write an equation in part B for r, and then we'll do a derivative so we can look at dr dt. So we need to relate the r to the other stuff we have here. Maybe. Okay, so the suggestion is the r over y, kind of like a proportional thing like we've done with the cone. The only problem is that the side of this thing is not a straight line. So as the water level changes, you know, as the water level goes lower, r is getting smaller, but not proportionally. The rate of change is changing because of the curve. Yeah. I love Pythagoras. Okay, so quick little note here. This is 13. This is r. That's a right triangle. We just need to know what that is. So I know r squared plus mystery something squared equals 13 squared. And the question is, how can we write that? I love 13 take away y. If the entire height of this center is 13 and the water level's y, wouldn't that part be whatever's left? So 13 minus the y. Okay, that's awesome. So this is just a squared plus b squared equals c squared, Pythagorean theorem, and then we're just going to basically solve this for r. Okay, so you can FOIL that out. There's not a reason to yet. We will eventually, but I'm not going to do it right now. Pardon me? What about positive or negative? Yeah, you're not going to have a negative radius, are you? Yeah, that doesn't really make sense. So I need to consider that issue, but it really doesn't make sense. This is part B. Now, can you FOIL that out? Yep. And we're going to need to when we go to doing the derivative. Well, you don't need to, but I would recommend it. Yeah. Part B does not say anything in my book about 8. Part C says find dr dt when it's 8 meters deep. Yep. That good? Y meters. Okay. Okay. I'm going to go ahead and start cleaning this up a little bit. Yeah, I just multiplied out the 13 minus y. Remember, you can't square 13 and square y. It's really 13 minus y times 13 minus y, and there's a whole outer and inner when you're doing all that distributing. So 169 minus 169 is nothing. Minus a negative 26 is really going to be plus 26y, and minus y squared. If you would rather write 26y minus y squared, you're certainly welcome to do that. Okay, so whichever form you prefer, this is good for B, this is good for B. When I'm doing part C, I want dr dt. Oh, that's a lot of rhyming. So I'm probably going to want it more like this. Yeah, more like this bottom one. In fact, I might write it so now dr dt is going to equal 1/2 times this whole thing to the negative 1/2. What's that? Cool. Thank you. dy dt. Okay, well that's annoying now, but that's what it is. Yes, thank you for the dy dt. I needed that. I don't need to do dy dt until I do the derivative of what with respect to y. This part was just du dy, and then this is dy dt, so I need a dy dt on the end. Yep. Yep. So this whole thing, and sorry it ran into the other part, but that's what happened. Okay, so I still need to put in the 8 meters deep. Okay, so dr dt. Well, I did the derivative with respect to the inside of this thing, so that was the whole 1/2 out in front to the negative 1/2 power. Then the derivative of the inside was this. I still have. Okay, I don't know what just happened, but it's very disturbing. Please tell me I didn't lose it. Okay, sorry about that panic attack Mr. Sanford just had. Yes. The, record. All right. Meanwhile, back on the ranch. So dr dt equals 1/2 times negative y squared. Well, y is 8, so negative 8 squared. Note that the 8 is squared, not the negative. Plus 26 times 8. I think I need more room. Yeah, it's grabbing most of it. That's funny. Leave it alone. All right. Following the formula here. So that's all to the negative 1/2 power, which we'll be able to just kind of type into our calculator, times negative 2 times 8 plus 26. And then dy dt, remember, was this number right here. Now, I don't know if I can just, it'd be cool if I could just grab that. Okay, negative 0.0, okay, somebody's going to have to remember that. Negative point. And remember, we really don't want to use a rounded version of that. Okay, so this is all stuff that just gets typed into the calculator. Obviously, this is a calculator-activated problem, right? This is not a no calculator. It's not no calculator. Okay, so type, and I'm going to cross my fingers and hope that we end up with about negative 0.553. Well, that's in centimeters. Sorry, my decimal's in the wrong spot because we did this all in meters. So negative 0.00553. This is meters per minute. Okay. All right, so that wrapped that up. I'm going to call this video done.